How many times has this happened to you? A customer tells you his engine-powered equipment won't start. Well, if the equipment has a battery-powered electric starter, there's a good chance that the battery is dead. In fact, a significant number of electrical problems presented to service technicians are no-start conditions directly related to dead batteries. You could replace the battery and send the customer on his way, but that may not correct the real cause of the problem. The real cause may be a failure in the alternator system. Although there are no moving parts to wear out, alternator systems can exhibit a variety of failures. Overheating, voltage spikes, improper jump starting, poor ground connections, and short circuits are the most common causes of alternator system failures. It's important that you find and remedy the cause of the problem, not just the effect. A dead battery is commonly a symptom and not necessarily the cause of the failure. Before you can use troubleshooting techniques to find the real cause, you need a thorough understanding of electrical theory. Today we're going to briefly review basic electrical theory, specifically how alternators work. This will include a look at some of the important terms you should know. We'll show you the best way to identify the specific type of alternator and how to look up its specifications. We'll demonstrate why a digital multimeter is your best time-saving tool for testing alternator systems. We'll identify several causes of alternator and regulator failures, and we're going to demonstrate proper testing procedures for troubleshooting those failures. It all starts with a fundamental understanding of what is supposed to happen. This is followed by testing to see if the system is performing properly, and then interpreting that test information to make a successful repair.
If you asked a group of service technicians what engine system requires the most time in troubleshooting and repairs, chances are the answer would be electrical systems. There are two reasons why electrical systems can be a problem for the service technician. First, electrical systems represent sophisticated, up-to-date technology in both design and production. This means you rarely see problems associated with these systems. Because you don't work on them as often, you're less familiar with them. Secondly, you cannot look at a wire to see if electricity is flowing through it in the proper amounts or in the right direction. For these reasons, this video will take a closer look at electrical systems, in particular the charging system. We will examine the theory behind its function, identification of the different types of systems, the proper testing of these systems, and finally, give you an opportunity to test your troubleshooting skills. Let's start with the theory used to explain the function of Briggs & Stratton alternator systems. Keep in mind that even though Briggs & Stratton systems come in all different sizes and shapes, we will use the same theory to explain the function of each. This theory is called the theory of induction. Three things are necessary to produce electricity using induction. First, there must be a conductor in which the voltage will be produced. Second, there must be a magnetic field in the conductor's vicinity. And third, there must be relative motion between the magnetic field and the conductor. Keep in mind, the amount of electricity produced will depend upon a number of variables, such as the size of the conductor, the amount of conductor exposed to the magnetic field, the size and strength of the magnets, and finally, the speed of relative motion between the magnetic field and the conductor. Now, there is one other minor factor, and that is temperature. However, the amount of temperature change experienced by our systems will not drastically affect the output of the system. Here are the components used by Briggs & Stratton to meet the three requirements of induction. First, Briggs & Stratton will use from 1 to 8 coils of conductor, depending upon the requirements of the application. A coil of conductor, in this case copper wire, is used to expose the maximum amount of conductor to the magnetic field. To meet the second requirement, Briggs & Stratton uses artificial magnets, either external flywheel magnets, which are also used for the ignition system, or a continuous band or row of magnets underneath the flywheel. By attaching the coils directly to the cylinder and the magnets to the flywheel, we achieve the third requirement, or relative motion. As the flywheel turns, the magnetic fields pass through the conductors, stimulating the movement of electrons. Now that we understand the components of the system, let's look at what they produce. When passing a magnetic field through a coil of wire, providing there is a common connection or load between the two ends of the coil, electrons will flow through the circuit and back to their source. As the magnets continue past the coil, the polarity or direction of the magnetic field will alternate. This change in direction will also alternate the direction of electron flow, producing AC, or alternating current. This type of system is commonly used as a lighting system on a piece of equipment. However, it cannot be used to charge a battery. Charging a battery requires direct current, or single direction current. A minor modification will be necessary to convert AC current to DC current. This modification is the addition of a rectifier. A simple half-wave rectifier consists of a diode. A diode is a one-way check valve, allowing electrons to flow in one direction only. Notice that with the addition of a half-wave rectifier, we only make use of half of the potential output of the system. If the size of the engine restricts the size and number of the magnets, or the size and number of the coils, replacing the half-wave rectifier with a full-wave rectifier can make full use of the potential output of the alternator, increasing the output of the system. But even this system has its limitations, because it is possible to increase the output to the point that it can cause damage to the electrical system, mainly overcharging the battery. To prevent this from occurring on larger charging systems, either a half-wave rectifier or full-wave rectifier is used in conjunction with a regulator. The regulator will vary the output of the alternator depending on the electrical demand of the system. That completes the basic theory of Briggs & Stratton alternators. Keep in mind that all alternators produce alternating current. It is only with the use of a rectifier that AC current is converted to DC current. This will be very important when it comes to testing alternators.
Once you've gathered this information, it's time to test the alternator. When it comes to alternator testing, there are only two basic types of tests. You will perform one or both of these basic tests depending upon the system. We'll demonstrate these tests in the digital multimeter portion of this presentation. That completes our look at the operating theory of alternators. Before you test an alternator, you need to identify the type of alternator system being tested.
In order to properly identify the type of system, three things are required. First, the number and color of the wires coming from under the blower housing. Second, the color of the connector at the end of the wire. And third, the engine model number. With this information, you can use either Section 7C of the Service and Repair Instructions or the Alternator Identification Chart to identify the type of alternator. Here are a couple of helpful hints for identifying alternator systems. First, scrape away any paint from the outside of the wire to be sure to get the correct wire color. Second, the fastest way to identify an alternator is by using the Alternator Identification Chart, form number 2288. Compare the wire color and connector color to the chart. If this provides you with more than one option, use the model series for further identification. This should narrow your options. Once the system is identified, make note of the type of output, the value of the output, and the speed at which the output should be measured.
We'll talk about testing the alternator in our next segment. To properly test an alternator system, you need a quality digital multimeter. However, the type or brand of meter is less important than the ability of the technician to use it. If you're already familiar with one type of digital multimeter, you should be able to use any type, even though there may be subtle differences. Whatever meter you use, a volt is a volt, and an amp is an amp. Briggs & Stratton offers and recommends the use of a Fluke digital multimeter because of its quality and durability. For all of today's demonstrations, we'll be using a Fluke digital multimeter. Digital multimeters are used to measure volts, ohms, and amps, and to test diodes when red and black leads are inserted into the appropriate receptacles. Let's take a close-up view of a typical digital multimeter. The symbols that you see on the front of the meter are usually consistent across the various brands of meters. They include volts AC, volts DC, millivolts, ohms, diode test with tone, amps AC, and amps DC. There are 3 receptacles on the face of the Model 73 Series 2 meter. The COM, or common receptacle, is always used for the black test lead when making measurements. The 10 amp receptacle is for the red test lead when measuring amperage less than 10. For amperage greater than 10, a shunt will be needed. The volts ohm receptacle is for the red test lead when measuring volts or ohms depending on the meter setting. This digital multimeter is equipped with a fuse to prevent damage to the meter in case the input limits are exceeded by mistake. If the meter displays a reading of 0.00 when testing DC output, check the fuse in the meter according to the operating manual. Your digital multimeter is a valuable tool. Knowing how to use it will help you quickly pinpoint the source of electrical problems.
The first test is to measure AC volts. An AC voltage test is used when the stator or stator harness does not contain a rectifier. The second test is measuring DC amps. A DC amp test is used when the stator or stator harness contains a rectifier. When performing an AC voltage test, set your multimeter to measure AC volts. Start the engine and check the engine RPM. Then connect one test probe to the alternator pin connector and the other test probe to a good engine ground and observe the reading. Compare the AC voltage reading with the specification given on the chart. If the output is within specification, the alternator is okay. If the output is below specification, recheck RPM and meter connections and retest. If the output is still low, replace the alternator. The next test is a DC amperage test. This test is used on alternators that contain a rectifier, either in the stator or in the stator harness. It can also be used to measure the output of the rectified and regulated system. The first step in this test is to properly set and connect your multimeter. When measuring DC amps, it is necessary to connect the battery in series with the meter. Failure to do this can cause damage to both the stator and the meter. Observe proper polarity when connecting the meter to the output pin of the stator harness. Connect the other test probe to the positive post to the battery and read the meter. The reading should not exceed 1 amp. If it does, the rectifier is shorted. Depending upon the type of system, you can replace just the rectifier, or you must replace the entire alternator. If the meter reading is below 1 amp, start the engine and check RPM. If the RPM is okay, check the amperage reading and compare it to the specification on the chart. If the reading is within specification, the alternator is okay. If the output is low, recheck RPM and the connections. If the output is still low, replace the alternator. Keep in mind that some alternators have replaceable rectifiers. On these systems, you can test and replace the rectifier separately. This same test procedure can be used with a rectified and regulated system, provided you remember 2 things. First, make sure you connect the meter in series with the battery as a load before starting the engine. This will reduce the likelihood of damage to the regulator. Second, the output of the regulated system, in most cases, will not match the rating of the system. Example, when testing the output of a 10-amp regulated system, the reading may be as low as 4 to 5 amps because the regulator will only allow sufficient output to meet the electrical needs of the battery.
Whenever we check a small engine, it's human nature that we look first at the easiest solutions, the things we feel most comfortable dealing with. If it's not already one of your comfortable areas, the alternator system should be. Even though there are no moving parts to wear out, alternator systems can exhibit a variety of failures. You need to feel confident that you have a basic knowledge of how alternators work, how to determine which type of alternator you're dealing with, and how to repair or replace them. When you understand the most common types of electrical system failures, their causes, and their remedies, you've taken a major step to satisfy your customer and earn their loyalty for years to come.